There's actually more than one way to do this on Desmos. I'm going to show you the way that I've been doing it with my other class, but then another Algebra 2 teacher showed me a different way, and I don't know which ones might be better. You can go into functions to find standard deviation. Here's functions, right? And you should be able to find standard deviation. It's this one. But you can also just type STDEV and find standard deviation. You're going to put the list in and separate it by commas. It does not have to be in any particular order. You can't have any spaces, though. Okay? So Desmos is telling me that it's about 3.5. I'm going to show you later another way to calculate it. It's very similar. It's just putting the list into the table. But this is one way. You can just put the list in separated by commas, and we're getting a standard deviation about 3.5. And we will find out very soon, what does that actually mean when I say my standard deviation is 3.5? But for now, we're just going to write down. So my standard deviation, 3.5. But remember, this standard deviation is a measure of the spread, just like range is a measure of the spread. The mean, median, and mode, those are measures of central tendency. So they do measure different things. All right, so we're going to start talking about normal distribution. Bless you. Raise your hand if you've ever seen a graph like this before with that shape. One person has seen a graph like this before. I'm not going to ask you to tell me anything about it. I just want to know if you've seen it. I think 5 people have seen it. Okay. All right. So it's called the normal distribution curve. It's also known as a bell curve. There can be controversy at times about the bell curve because some things are normally distributed as the bell curve, and some things people believe are normally distributed, but they may not actually be. Everything under the curve adds up to the number 1 because 1 represents 100%. Okay, so the area under the curve is 100%, and as a decimal, 100% is 1. When you're trying to find a probability, you can show your understanding by shading the curve. Or writing a probability statement. All right, so when you are shading the curve, you have some value x. Here's my x. And I'm trying to find the probability that that a certain number would be less than that x. And that would be represented over here. That would be what I would be shading. One thing that's good to know is that the number in the middle is the mean. We use the mean, but if things are perfectly distributed, perfectly normally distributed, it's actually the mean and the median and the mode are all the same number. But we're using the mean, and this mu represents mean. All right, so you will be able to use calculators to find the probability that x is less than a given number. If you want to find the probability that it's greater than a given number, then you would subtract this percent from 100%, which in decimal would be you would subtract from 1. Okay, so there will be calculators that will help us with some of that. However, because things that are normally distributed follow a predictable pattern, there are percentages that come up more often. and they're based on standard deviations. The empirical rule has another name that's very helpful because it helps you remember the numbers. It's called the 68, 95, 99.7 rule. Here's why it's called that. In a normal distribution, when you have a mean, this here is your mean. It's really small. Your mean is the mu right here. This is one standard deviation above the mean, and this is one standard deviation below the mean. Two standard deviations above, two standard deviations below. 3 standard deviations above and 3 standard deviations below. When things are normally distributed, 68% of your data points will be within one standard deviation of the mean. Think of heights as an example. Okay, American women, heights are normally distributed, and there's a mean height. And most people, 68% of people, are within one standard deviation of the mean. Now, we don't know how big that standard deviation is. You can look it up. It's, it is a set number. But 68% of women would be within one standard deviation of that mean. But even more powerful is 95% of women are within 2 standard deviations of that mean. And then 99.7% of women would be within 3 standard deviations of that mean. That's almost everybody. So outliers are considered anything that are 3 standard deviations above or below the mean. Okay. They're called outliers. They're not trying to be mean. They're just saying you are uniquely tall or uniquely short if you are more than 3 standard deviations above or below the mean. So take a moment and see if you can notice the relationship between the numbers in the 2 charts. See here how we have 68% is 1 standard deviation below to 1 standard deviation above. And then in this chart, they split that 68 into 2 pieces, 34 and 34, right? Here we've got 95%. So 95%, if I subtract out the 68%, that's 27%. Half of the 27% goes on this side and half on this side, okay? So really, these are the same sets of numbers. They're just demonstrating the percentages a little bit differently. Does anybody have a question on this page? It's all a little bit easier when you see it in context, so we're going to get to some context. Okay. Yes. I don't think you did. I think it might have been middle school last time you did it. Maybe you did in Algebra 1. But, I mean, sometimes teachers will throw in something at the end of the year, so you might have. All right, suppose the average score on a French quiz was 37 with a standard deviation of 7 points. Draw a diagram. Make sure to label the mean and 3 standard deviations in each direction. So we're going to do our best to draw a pretty bell curve. I am not artistically inclined, but do your best to make it symmetric. And in the middle, we're going to put not the mu to represent any mean, but we're going to put the actual mean, which is what number? 37. I hope that's not out of 100. That would not be a nice score. All right, standard deviation of 7. That means that 1 standard deviation above the mean would be 7 more points. So 44. 2 standard deviations above, you add 7 again. And here's 3 standard deviations above, and that's 7 again. On the left side, you're going to subtract 7. So we don't keep going with standard deviations. The curve will always have 3 above and 3 below. All right, and in order to answer these questions using the empirical rule, it will be helpful to copy the percentages from the second graph. So that would be 34% in each of the center ones. And then 13.5%. 2.35%. I'm going to not write the percent there, but it is a percent. And then 0.15%. When you look at the number 0.15%, remember that that's different from the number 0.15. 0.15 is 15%. 0.15% is less than 1%. It's really small. I just didn't put a percent on the 2.35 because I ran out of space, but everything else, everybody actually is a percent. All right, so I'll do one and then I'll give you a moment to figure some out. For B, it says, what percent of students score between 30 and 37? 30 and 37, that would be 34%. Okay, so a lot of students score between 30 and 37. So from 37 to 44, you should have also had 34%. Between 23 and 37, you had to add these two up. So 13.5 plus 34, and you got 47.5%. All right, below 30. Did anybody just add all 3 of these up to get below 30? Yeah? Did anybody use a different method besides adding those 3 up? Okay. You could have also thought, okay, well, this is 50, right? And then that's 84. So you might have done 100 minus 84. But it works that way too. You guys did 0.15 plus 2.35 plus 13.5, and you got 16%, right? Beautiful. All right. So then if there were 26 students in the French class, how many of them scored below 23? So what was the percent for below 23? 2.5, right? So we've got 0.15% plus 2.35% is 2.5%. How do I find 2.5% of 26 students? Do you guys ever calculate a tip in your head? Never? I know they always tell you what the tips are, right? They're like, do you want to give me $5, $10, or 15? I'm like, well, I don't know. So to calculate a percentage, you have to convert it to a decimal, and then you multiply. So what's 2.5% as a decimal? 0.025. Good. So you can divide it by 100 if you didn't know that to get your 0.025, but this is how you do it. You do 0.025, that's the decimal for 2.5%, times 26 students. All right. Now we're going to get a decimal, and we can't have a decimal student, so we're going to have to round it as our nearest guess. Estimate, I would say, rather than guess. So I'm getting 0.65. Can anybody confirm that? Okay. Okay, so that means approximately 1 student. Although I wouldn't be surprised if it was 0 students, because that's not too far above a 0.5, but Our best estimate is one student scored below 23. All right, we have one more problem, and then we're going to just do a practice worksheet today at our desks. I know it's unusual. I mean, if you feel like taking your practice worksheet and putting it on the board and doing it on the board, you can do that. That's fine. The heights of adult American males are approximately normally distributed with a mean of 69.5 inches and a standard deviation of 2.5 inches. I don't know if that's true. Sometimes these problems have real data. Sometimes they have made up data. You can look it up though. You can find, actually, I looked this up with my son the other day because he really wants to be really tall. And so he wanted to know how many standard deviations above the mean he was. He was not happy with the result. But there is actually a couple different measurements up there on mean and standard deviation. So there might be a little bit of discrepancy. But we're going to deal with the data we have here. So mean of 69.5 and standard deviation of 2.5. Draw a diagram. So draw a diagram. Let's do that now. And then write probability statement to support your answer. And I'll show you what I mean about probability statement. All right, so we got our mean, and then 3 standard deviations on each side. $69.5, and then add 2.5. I am adding 2.5. If you can't read my numbers, I think you can figure it out still. If I get one wrong, feel free to tell me. All right. What percent of American males are between 67 and 74.5 inches tall? So 67 and 74.5. Now, I don't have to rewrite the numbers, the percentages every time. They're going to be the same regardless. So I'm going to add those up. And actually, let me show you what the probability statement looks like. Probability that X is between 67 and 74.5. And you're going to add up your percentages. So I had 34, another 34, and a 13.5. Okay, so the probability that they're between 67 and 74.5 inches, you add up your probabilities, and you get this. Yes.
Did you say that was 74.5?
That's what I said. Did I make a mistake? Oh, you just can't read that number there. Yeah, I get you on that. My numbers, I got 62, 64.5, 67, 69.5, 72, 74.5, and 77. All right. So I would like you guys to try B and C. And when you write your answers, instead of just writing a percent, try to write the probability statement as well. And then we add up 0.15% plus 2.35% to get 2.5%. All right, C, in a group of 2,000 males, how many would you expect to be taller than 6 feet? 6 feet is how many inches? 72? Okay. So the probability that X is greater than 72. I'm gonna add up these 3 sections. I got 16%. Am I done answering the question? No, because I need to find 16% of what number? Of 2,000. Okay. So Sally, what did you multiply to find 16% of 2,000? Okay. And you got what? 320? Okay. So 320 of those people would be taller than 6 feet.